Welcome to the lesson on micrometers. Upon completion of this lesson, learners will be to locate, identify, and label the parts of a micrometer and vernier micrometer, identify the types and sizes, and explain the measurement process for a micrometer. The micrometer, used for precise measurements of length, is today's most widely used precision measuring tool. Micrometers are more widely used than vernier calipers because their scales are a bit easier to read. As a result, they produce fewer reading errors and, with a vernier scale, can measure precisely up to 10,000ths of an inch or 10,000ths of a centimeter. Before we learn how to use a micrometer, it is important to know the 9 parts of the caliper. They are anvil, spindle, lock nut, sleeve, thimble, ratchet stop, reading line, frame, and size and accuracy. We will discuss more about these parts in the next 2 slides. Part 1 is the anvil. The anvil is static. The workpiece should rest against the anvil with the spindle moving towards it. Part 2 is the spindle. The spindle moves toward the anvil to tighten the workpiece in place and produce the correct measurement. Part 3 is the lock nut. The lock nut locks movable parts in place for more accurate measurement. Part 4 is the sleeve. The sleeve or barrel is a stationary part with the scale etched onto it. Part 5 is the thimble. The thimble is used to move spindle toward and away from anvil. Part 6 is the ratchet stop. The ratchet stop helps to limit the pressure applied to the workpiece. Once the workpiece is tightly in place, the ratchet screw slips, letting the user know that a measurement can be taken. Part 7 is the reading line. The reading line, which is found on the sleeve or barrel, is the main scale on the micrometer. Part 8 is the frame. The frame is the C-shaped body of the micrometer. And lastly, Part 9 shows the size and accuracy of the micrometer. Every micrometer will have the following details etched on it: the units of measurement, inches or centimeters, the measurement it can read, and occasionally the accuracy at which a measurement can be read. That is 0.001 inch or 0.0001 inch. Just like calipers, there are 3 basic types of micrometers: the inside, the outside, and the depth micrometer. The images you see here show each of the 3 different types of micrometers. All micrometers are read the same way, but are specialized for the type of dimension measurement needed. Micrometers also come in different sizes, but they can only truly measure up to an inch. For example, a 4-in, 5-in. Micrometer will open up to 5-in, but can only be used to determine with precision a measurement between 4-in and 5-in. This slide shows 3 different sizes of micrometers: a 0 to 1 inch micrometer, a 4 to 5 inch micrometer, and a 7 to 8 inch micrometer. As you can see, the size of the sleeve is exactly the same in all 3 because each measures only up to an inch. Which size micrometer you use will depend on the size of the object you are measuring. Using a micrometer has become a necessary task in every type of industry. Following the steps below, you will be able to master the use of the micrometer. First, be sure that the lock nut is loose. Second step is to close the spindle to ensure a measurement of 0 on the scale. Third step is to open the spindle. Step 4 involves multiple sub-steps. Hold the micrometer, except for larger sizes, in your right hand with your little finger pressing the frame against the palm. Place the 4th finger just above the lock nut and use your thumb and index finger to turn the thimble. The middle finger will be used intermittently for support. Hold the workpiece in your left hand and place it between the anvil and the spindle. Turn the thimble with the sleeve until contact is made. Step 5 involves turning the ratchet stop when the contact is made. When the proper pressure is reached, the ratchet will turn without moving the spindle. 6th step is to tighten the lock nut. Lastly, read the measurement as discussed in the next slides. Reading a micrometer is similar to reading a vernier caliper. Refer to the English micrometer seen here. Each large graduation on a micrometer sleeve scale corresponds to the first decimal place, or 0.100 in. This is then divided by 4, making the next graduation on the micrometer sleeve scale correspond to 0.025 in. The scale on the thimble has 25 graduations. Each of those correspond to the 3rd decimal place, or 0.001 in. To get started, let's look at this example. First, we identify that we are reading a 1-inch depth micrometer. Because of this, we know that our measurement will have to be less than 1 inch. Next, we know that each large division is 0.100 inches each. From the scale, we see that the smallest visible number is 6. Therefore, the first reading we have is 0.600 inch. There are no visible 0.025 inch graduations after the large division. Therefore, the next reading is 0 times 0.025 comma, which equals 0.00 inches. The final reading is obtained from the thimble scale. Each graduation in the thimble scale is 0.001 inch. The thimble reading is right at 7. Therefore, the last reading is 7x 0.001 inch. Adding in these three readings, the measurement is 0.607 inches. Now, let's look at an example of an inside micrometer that is measuring an object between 3 and 4 inch. By looking at the picture, we can clearly see that the measurement will be less than 4 inches. Therefore, our first reading will be 3.000 inches. Let's look now at the large divisions, 0.100 inch each. From scale, we see that the smallest visible number is 2. Therefore, the second reading we have is 0.200 inch. There are no visible 0.025 inch graduations after the large division. Therefore, the next reading is 0 times 0.025, which equals 0.00 inch. The final reading is obtained from the thimble scale. Each graduation in the thimble scale is 0.001 inch. The thimble reading is right at 0, therefore the last reading is 0.000 inch. Adding these three readings, the measurement is 3.2 inches. Some micrometers have a vernier scale on the sleeve. These micrometers are the most precise of all tools presented in this module and can measure accurately a 10,000th of an inch. The vernier scale generally has 10 graduations. The reading provided on the vernier scale is the fourth decimal of the total reading. Therefore, each graduation of the vernier scale represents 0.0001 inch. The vernier scale reading corresponds to that of the graduation, aligning with the graduation on the thimble scale. First, we know that each large division is 0.100 inch each. From scale, we see that the largest visible number is 3. Therefore, the first reading we have is 0.300 inch. Also visible are three 0.025 inch graduations after the large division. Therefore, the next reading is 3 times 0.025, which equals 0.075 inch. The next reading is obtained from the thimble scale. Each graduation in the thimble scale is 0.001 inch. The thimble reading is right at 16. Therefore, the reading is 16 times 0.001, which equals 0.016 inch. The last reading comes from the vernier scale. The thimble scale and the vernier scale align perfectly at 0. Therefore, the last reading is 0 times 0.0001, which equals 0. Adding these three readings, the measurement is 0.391 inch. Now, let's look at the example of the 7-inch to 8-inch outside micrometer. This micrometer is measuring an object between 7 in and 8 in. This means our measurement should be between 7 and 8 inches. By looking at the picture, we can see that only a portion of the sleeve scale is shown, and measurement will be less than 8 inches. So, we can determine that our first reading is 7 inches. Let's look now at the large divisions, 0.100 inch each. From the scale, we see that the largest visible number is 4, making the second reading and first decimal place we have is 0.400 inch. After the 4 on the large scale, there are two visible 0.025 inch graduations. Thus, we can determine that the next reading is 2 times 0.025, which equals 0.050 inch. For the thimble scale reading, each graduation in the thimble scale is 0.001 inch. We see that the thimble scale aligned with the vernier 0 is between the 20 and 21 graduation. Therefore, the reading is 20 times 0.001 inch, which equals 0.020 inch. Finally, the last reading is obtained from the vernier scale. The thimble scale and the vernier scale align perfectly at the 3, which makes the last reading and fourth decimal place 3 times 0.0001 inch, which equals 0.0003 inch. Adding these readings, the final measurement is 7.473 inches. In summary, reading the vernier micrometer involves the most complex process, as this instrument uses 3 scales, thimble, sleeve, and vernier, to provide a measurement. However, this instrument is also the most precise of all tools presented in this module. It is important to understand how to read micrometers and vernier micrometers, as these tools are commonly used in industry for both their speed and accuracy. Thank you.